Welcome back everybody to part 2 of the 9.7 video series. We're on our way to being able to solve all triangles, not just right triangles. But an intermediate step that I'd like to take a look at, mostly because it's pretty cool, is that we can actually use trigonometry to find the area of any triangle. And this is also going to bring into account what we did in the last video about finding the trigonometry of obtuse angles. So if we have triangle ABC, with opposite sides, A, B, and C, as labeled, we can actually find the area of this triangle without having to know the height of the triangle. We're so used to finding the area of the triangle as 1/2 the base times the height, where B is the base in this particular case. But we don't always know the height of the triangle, and it's not always that easy to find in non-right triangles. But now that we have the height drawn in there, hypothetically anyway, we can find that the sine of A should be equal to h divided by c, since h is the side opposite to A and c the hypotenuse of what is now a right triangle. So this, as we said, the area of triangle ABC is 1/2 BH, whatever B and H happen to be. But my cat, who's been staring at me non-stop for the last 12 days, is telling me that the area of triangle ABC can actually be written as 1/2 B times C times the sine of angle A. Well, we already have one formula for area, 1/2 BH. Let's see if we can transform my cat's formula into 1/2 BH and show that they're exactly the same thing. Alright, so this is where we're beginning. We'd like to translate that into this. Well, let's rewrite the sine of A for the figure that we're looking at. So this is now equal to 1/2 BC times h divided by c. Well, that opposite side divided by the hypotenuse. From here, things fall pretty clearly into place. These c's cancel, since the c on the outside of the parentheses is in the numerator of a fraction, and that inside is in the denominator. That leaves us with, remarkably, 1/2 BH. So in the case that we don't know what h is, we can use this alternative formula. Now it should also be the case that I can do the exact same thing using any of the three angles. Whether I care about angle C because I happen to know that, I care about angle B because I happen to know that, what these formulas are saying is that I can find the area by finding the sine of a given angle and knowing the lengths of the sides opposite the two other angles. So if instead I happen to know C, then the sine of C, B, and A should give me enough information to find the area of that triangle. And of course, it makes sense why this would be the case, because we know that the sine of C, for instance, is equal to the opposite side over the hypotenuse. Well, that's just h over A. So that implies that the area is equal to 1/2 A, B, h over A. Again, the a's cancel, and we wind up with the same formula we've always had. So no matter what the angles are that we know, as long as we know an angle and the two sides that include that angle, we can find the area of a triangle. Let's take a look at a quick example. Let's say we have triangle XYZ here. We know that side Z is 10 units long and side X is 14 units long. We don't know the length of side Y, but in this case it's not particularly important, because we can say the area should be equal to 1/2 Z times x, and most importantly, times the sine of the included angle, which here is angle y. Well, there's certainly one thing we need to figure out in advance, and that's, what the heck is the sine of y? Well, let's run to the calculator and take a quick look, considering that we know that y is 115 degrees. 0.9063. Now we have all the information we need to complete this entire formula. Now it's just a matter of calculation. Let's run back to the calculator and do that. Notice how I've put in the answer for the previous line so I can pull the sine of 115 degrees directly from there and have it be a little bit more accurate than when I rounded it to 4 decimal places. And it seems that the area of this triangle should be about 63.44 units. And we're done. We relied on a little bit of knowledge of the trigonometry of obtuse angles, but once we know that we can find the area by taking two sides and the sine of the angle between them, and dividing all that by 2, it makes this problem a pretty simple one. I think that's all we need on this. You'll have an opportunity to do some practice in an upcoming assignment. I think that's all we need for today.